Hello and a warm welcome to the AI with Arun show. The image that you see here is not science fiction anymore. It represents the future of medicine, a future where AI is a powerful partner and a co-pilot, as we like to call it. So let's dive in. The healthcare industry is at the cusp of a major transformation, and the numbers prove it. The healthcare AI market was valued at $19.27 billion in 2023, and it's projected to grow to a staggering 187.7 billion by 2030. This growth is not just about new technology. It's about a fundamental shift in how we approach health and treatment to operational efficiencies. One of the most immediate and impactful applications of AI is in precision diagnostics. AI's ability to process massive amounts of data is revolutionizing how we identify diseases, allowing for earlier and more accurate detection. For example, AI can analyze medical images in radiology and pathology and process electronic health records, EHRs, to improve accuracy and save time. A great example of this is how AI can classify brain tumors in less than 150 seconds, a task that typically takes a conventional method 20 to 30 minutes. It can also detect subtle signs of Alzheimer's on FDG PET scans that are not visible to the human eye, enabling earlier predictions of complex conditions. AI can also provide clinical decision support by offering evidence based guidance to medical professionals. This means doctors can leverage the collective knowledge of millions of cases to make better informed decisions. Beyond diagnostics, AI is also driving a revolution in personalized treatment. This is about moving away from a one size fits all approach to medicine and creating individualized strategies. First, AI can generate customized treatment plans by evaluating a patient's unique genetics, biomarkers, and other health factors. Second, it can predict how a patient will respond to a specific treatment, helping doctors identify who is more likely to benefit or experience adverse effects. Finally, AI can integrate with wearable devices for continuous monitoring of a patient's health. This allows for early detection of issues and agile adjustments to treatment plans. This approach turns treatment into an evidence based predictive process rather than a trial and error one. Now, AI's impact is not limited to patient care. It's also streamlining. So, AI's impact is not limited to patient care. It's also streamlining healthcare operations and accelerating drug discovery. Now, in terms of operations, AI is helping with managing EHRs, as we mentioned earlier, the electronic health records, using natural language processing, then automating or appointment scheduling and optimizing staff allocation, predicting resource allocation needs and automating revenue cycle management, and providing chatbots to handle patient inquiries. When it comes to drug discovery, AI is drastically speeding up the process by identifying potential new therapies from massive databases, predicting drug target interactions, which can save up to 25 to 50% of the time it takes to find new drugs, optimizing clinical trial design and patient recruitment, and using digital twins to reduce the need for animal testing. Now, these applications are addressing critical bottlenecks, improving efficiency, and accelerating innovation in healthcare. In addition to AI, robotics is playing an expanded role in medicine. The medical robotics market is projected to go to 63.8 billion by 2032. In surgery, robotics like Da Vinci and CyberKnife are improving clinical outcomes by enabling greater precision, which can lead to less blood loss, shorter hospital stays, and reduced opioid use. Robots are also assisting with patient care, such as delivering medications and performing sanitation tasks to reduce hospital acquired infections. Some can even perform life saving protocols like CPR. Finally, robotics is enhancing diagnosis through technologies like magnetically controlled capsule endoscopy and automated breast ultrasound systems. Looking ahead, the future of AI in medicine can be broken down into two phases. In the immediate future, which is like 0 to 5 years, we will see AI primarily as a clinical augmentation tool. This means early detection of anomalies, real time support for at risk patients, and the automation of administrative tasks. Physicians can now be able to see initial cost reductions. In the midterm, which is like 5 to 10 years range, this is where things get even more exciting. We will have data informed personalized medicine and real time adaptive treatments. This will lead to a redefinition of professional roles and the emergence of new interdisciplinary jobs. We can also expect significant cost reductions of over 50%. The key takeaway is that AI will handle the data heavy, repetitive, and analytical processes, freeing up humans to focus on creative problem solving, emotional interaction, and leadership roles. Now, with the promise of AI is immense, there are critical challenges that we must address. One is algorithmic bias and fairness. AI models are only as good as the data that they are trained on. If that data is unrepresentative, the models can perpetuate health disparities. For example, a cardiovascular risk algorithm was found to be less accurate for African American patients because 80% of the training data came from Caucasians. Two is about data privacy and security. AI's reliance on vast data sets raises serious concerns about patient privacy. Complete anonymization is difficult, and sharing data across institutions increases the risks of security breaches. The third one is about accountability and transparency. The black box nature of many AI systems makes it difficult to understand how they arrive at a conclusion, which complicates assigning responsibility for errors. This is particularly a concern when a large language model hallucinates or produces misinformation that could mislead clinicians. Addressing these challenges requires proactive ethical frameworks and transparent governance to ensure that AI is a force for good. There are also practical and human considerations to navigate. Now, in terms of implementation hurdles, integrating AI is not always easy. We face challenges like the lack of an empirical evidence from clinical trials and outdated AI infrastructure. Then, patient clinical relationship. While AI can free up time, we need to ensure that time is used to enhance the human connection, not just see more patients. We also have to address patient distrust and the risk of clinicians becoming overtly reliant on AI and losing their skills. So, how do we prepare for this future? It requires a new set of essential skills. First, we need to develop data analytics and machine learning literacy. This means understanding how to interpret data and critically evaluate the outputs of AI. Second, we must learn to effectively use AI powered tools. We must know how to integrate AI tools into our workflows, interpret the results, and understand their limitations. Third, and most importantly, we need to lean into our human strengths, which is critical thinking and ethical reasoning. This includes questioning AI outputs, applying human reasoning to complex decisions, and maintaining empathy and communication skills. And finally, we need to embrace the human AI collaboration. This is about excelling in roles that use AI to enhance human output, fostering teamwork, and committing to continuous learning. To conclude, the future of medicine is not about AI replacing human practitioners. It's about AI empowering them to provide better, more personalized, and more accessible care. This demands a strategic investment in reskilling the workforce and fostering a culture of continuous learning. By embracing AI with purpose and a strong ethical compass, we can harness the revolutionary technology to improve the human well being for generations to come. That brings us to the end of the show. Thank you for watching. Like, share, subscribe, and support our work by joining us as a member.